In this section, we're going to learn how to solve quadratic equation by completing the square method. This is also very useful, especially when you have a quadratic and you need to identify the vertex. And so this particular skill allows us to transform those kinds of equations. So here are three examples of multiplying out a binomial squared into something called a perfect square trinomial, which ended up being these from the ones that are up above here, these guys right here. So if you take a look at them, they actually start to have some sort of a pattern that you can actually start to observe. So if you noticed, when you FOIL it out, the numbers that are underlined here actually has common numbers. And if you really look into it, you can see that when you actually look at the middle term, if you divide it by 2 and square it, then you'll get this number 2 squared. In this case, that gives you the last term. And it's the same for all the other ones. If you take the middle term, you divide it by 2. If you square it, it actually gives you the last term in that particular trinomial. So this actually allows us to transform, we can actually transform particular quadratics into a perfect square binomial. So in general, we have something where if you take the middle term and you divide it by 2 and then square it, it actually is the last term. And notice you can also even go backwards by understanding that if you just take the term in the middle and divide it by 2, that also gives you the second term of your binomial. So here's an example where they're asking you to find the value of c, and again, this is off your worksheet, to make it into something called a perfect square trinomial. So basically, if you change it back into a binomial, it's a binomial squared. So they're asking you to find that third number that's actually going to allow you to transform it into a square of a binomial. So in this case, again, if we go ahead and follow the patterns that it actually has, if we go ahead and take the middle term here, divide it by 2, and then square the whole thing, and then simplify it, you'll find out that the third term that would work here would be 144. So we go ahead, and if we write that in place of that, then we do get this trinomial x squared minus 24x plus 144. And converting it into a binomial is now easy because the number that's inside before you square it is going to be the second term of your binomial square. So here's another example, again off the worksheet. Again, you can try and do this by yourself. But again, I am looking for that third number in the sequence. So again, if I go ahead and take the 10, divide that by 2, and then square it, and then simplify it, it'll actually give me that third term that I need. So this would be x squared plus 10x plus 25. And again, if I want to change this into a square of a binomial, we just have to take the number that is inside before you square it and put it in the second spot of the binomial. So again, completing the square is just another way to solve a quadratic like this. Again, you can use other methods such as factoring. In this case, that wouldn't work nicely. Quadratic formula also works. But again, we want to go ahead and practice this particular skill. So the first thing that you want to do is you want to actually take out the 13. There is other ways you can do this, but it's just easier if you actually get the third term that it doesn't make this work into a squared binomial to the other side of the equation. So the first thing I'm going to do here is go ahead and subtract 13 from both sides. So once you get that, the idea is to actually add that third term like we did in the previous example. But please understand that if you have an equation, if you decide to go ahead and add in that third term, because it's an equation, you must add another term to the other side here as well, just because it's an equation. So again, if we go ahead and take the number in the middle, divide that by 2 and square it, that'll give us our third term. But again, that same term should also be done on the other side as well for the property of equality. So if we fix this, we get x squared minus 10x plus 25. And again, the other side, we'll go ahead and fix that up. Again, you can see it's a trinomial. Now we can make it into a squared binomial by taking that middle term and dividing it by 2. And then we'll go ahead and simplify the other side. And then to solve it, it's just like the previous section where we go ahead and square root both sides to get rid of the squared. And if we go ahead and simplify that, remember it's a plus or minus on the right hand side. We're going ahead and add the 5 to both sides. And then we are going to go ahead and write that together. Remember, they're not like terms. But remember, once you get to this point, you want to make sure that your radical is simplified. In this case, it's not. We know that 4 times 3 has a perfect squared factor there. And this becomes 2 square root of 3. So your final answer here is 5 plus or minus 2 square root of 3. So here's another example. Again, you can try this on your own, but the most important part is when we're actually doing the completing the square method, it's actually easier if the coefficient to x squared here happens to be a 1, and in this case it happens to be a 3. Luckily, the 3 actually divides out of every single term that's in this equation. So that's the first thing I do, is actually try to make it so that I have a coefficient of 1 next to x squared. So if we divide that out, we get x squared minus 4x plus 7 equals 3. And again, I want to go ahead and I notice that if I truly can make this trinomial into a squared binomial, this number here should be a 4. So because it's not, I'm going to go ahead and move that to the other side of the equation by subtracting it from both sides. And then now again, I want to add a number. In this case, I do want to add a 4 here. But remember, you also have to add the same number on the other side. So again, we will take the middle term, divide that by 2 and square it. Do the same thing to the other side because we want the same values. If we go ahead and simplify that, we get x squared minus 4x plus 4 equals negative 7 plus 4. This is now a trinomial where I can make it into a squared binomial. And fix the other side here, which is negative 3. So again, we're back to the section where we're solving by just squaring rooting on both sides. And if we do that, you notice this is going to be an imaginary answer. So if we have this, we get x minus 2 equals plus or minus square root of negative 3. And then from here, I'm going to simplify the negative out of the radical by using the variable I, and then add 2 to both sides. And ultimately, the final answer will be x plus or minus, x equals 2 plus or minus I square root of 3. Okay, here's the next example. Now, if it wants it in vertex form, you got to first understand or remember what vertex form is. So vertex form is something we studied a little while back, but it's y equals a times x minus h squared plus k, where h and k is a vertex. So if you noticed in this particular equation, and let's write down the actual problem here, you notice that this part looks like a binomial squared. So we want to use this method of completing the square to get that particular piece into this equation. So again, just like the other ones, I know that this 95 here is not the number I want as a third term to change this entire thing into a squared binomial. So I'm going to go ahead and subtract 95 from both sides. So we get y minus 95 equals x squared minus 18x. Now again, I want to find that third term that fits in that spot, so I'll just go ahead and make some spaces here, knowing that whatever I decide to add here, I'm going to have to add over there. And so again, same thing, I'm taking the middle term. I will go ahead and divide that by 2 and square it. That same value goes on the other side of the equation. And then we'll get something that looks like this. Okay, and now the trinomial over here can now be written as a binomial. So y minus, let's go ahead and simplify that at the side. Y minus 6 equals to x minus 9 squared. And now the final thing is to go ahead and add 6 to both sides. So now that it actually structures like the standard form over there of the or the vertex form of a quadratic. And so remember, in this case, your h's fit in that spot, the k is in that spot, so you can identify your vertex now as 9, and 6.